Hi, this is Gigi from Kauai Community College. This is the derivative cards, the red ones, and this is problem number 2 on the cards. Um, it involves, in this case, a function f of x having a quotient and a product on the numerator. Okay, do you see what I mean? There is a quotient, which is a division problem here, and a product on the numerator. Okay, so things that we should know. First, the derivative of a product is the derivative first times the second plus the derivative of the second times the first. Okay, so that's one thing we should know. Second thing we should know is the derivative of a quotient. The quotient rule, that would be the derivative of the first times the second minus the derivative of the second times the first, all over the second square. That's the quotient rule. Okay. The next thing that we should know are basic derivative for these functions. So we know that the derivative of sine of x is cosine of x. And the derivative of cosine of x is negative sine of x. Okay, so those are the basic derivative and also the derivative of x, which is x to the n power. In this case, n being 1, the derivative of x to the n power is n times x to the n minus 1, right? So those are the basic rules and derivatives that you should know in order to do this problem. Okay, so let's apply. First, this is a quotient where the product is embedded inside this quotient. So we're going to have to apply the quotient rule first. So then the derivative of f of x is, okay, and let's plan ahead. I know whatever it is, the bottom going to be the bottom square, 1 plus cosine of x, and then square. Okay, now the numerator is sine of x sine of x. Okay, it's x sine of x. So product rule will apply when I take the derivative of the first. So the product rule said the derivative of the first, which would be 1 times sine of x plus the derivative of sine of x would be cosine of x multiplied to x. Okay, that's the derivative of the first of the numerator multiplied by the denominator, which is 1 plus cosine of x minus the derivative of the denominator, which would be negative sine of x multiplied by x sine of x, the numerator. Okay, so that is the quotient rule, the derivative of the first. If we were using these notation, the derivative of the first times the second, and then the derivative of the second times the first, and there's a minus right there, divided by the second square. Okay, using those notations there. Now it's not cool for me to use the f and the g because this is a function f already. So I don't know, you could use a, b, c, whatever, as long as it's not the same as the function that you have called here being f, right? Okay, so we now need to simplify and clean that up. Let's see what we can do. 1 plus cosine of x squared. The numerator would be, when we distribute, we would get, well, that's a very long distribution right there, right? So this would be sine of x multiplied by that. Okay, so that would be sine of x plus sine of x cosine of x. And the reason why you would see that I dropped the parentheses there, because it's just a lot of writing. I know it's mathematically correct. It's just a lot of writing to say sine parentheses of x, right? So up to you on how you write that, but make sure you understand what it means. Okay, second, we're going to distribute this. So that would be plus x cosine of x plus cosine square of x minus is going to be a plus, and this would be sine of x. Sine of x is sine of x squared, right? And then we have x sine square of x. Okay, whenever I see sine square of x, cosine square of x, I think that is 1. So that right there could be a factor. Can it be factored out? I don't know. Oh, what else can we do? Not much. Not much. So we will say, oh, I don't know. Is there anything that we could do? So at this point, you would say, you know, is there any identities I could use? Is it worth my time? I think at this point, I'm going to say, no, not really worth my time to have to simplify all that unless I am required to. So I'm going to stop right there.